This is ECE461 Challenge Assignment 2 demonstration video, part 2. In this video, I'll walk you through all the code that I wrote. So let's start from the beginning. We have all these initialization, watchdog timer, GPIO. This actually initializes all the GPIOs to input with a low pull-down resistor. This is actually one of the URP advisors' advice to optimization of power. In the LED, which initialize all the LEDs, GPIO pin, clock setup, set up the clock, timer setup. Timer setup actually I initialize two timers here. One is for clearing the watchdog timer. So every time the interrupt goes out, it clears the watchdog. This one is actually the driving timer, the PWM driver for the ADC. So this is set up at 10 Hertz using a clock, just 32 kilohertz. Counts up to 3,277. So it's a 10 Hertz clock period with a 50% duty cycle. This is used to drive the ADC. So ADC will sample the input pin every 10 times every second. So button setup, this will set up all the buttons, output pin as well, input pin, set up the watchdog timer. The watchdog timer is set up to go at 16 seconds, every 16 seconds. Enable the interrupt. Alright, so here's the main part, ADC init. The ADC is set up to be in compared window mode, which means that I give it a lower threshold and a higher threshold. And it will only, even though it's sampling at 10 times a second, it will only trigger an interrupt if that sample is below the low threshold or above the higher threshold. So right now I have only the low threshold interrupt enabled, so it will only generate the interrupt if the sample is below the threshold that I set for it. Since the ADC, the value is inverted, as the sound goes higher, the actual sampling value goes lower. So this is used to generate registered interrupt, which is right here. We'll talk about it later. This is one of the main interrupt that I have. This is used to initialize the I2C function. I used the example code, and this is used to initialize the OPT3000 light intensity sensor. I also use the example code, but I modify quite a bit actually. Instead of constantly talking to the sensor via I2C, I put it into what they call a latch window style comparison mode. This is pretty much exactly like the ADC. Instead of giving me every value, it will set a GPIO interrupt. It will set an external pin to low once the value goes below a certain threshold. So you can see here that I'm setting up this pin for the GPIO that's going to enable the interrupt. So this pin is connected to the int pin on the light sensor, pin 4.6, and it's going to set off the interrupt from high to low transition since the pin is active low. And here we send a configuration. I configure the value. I have to read the data sheet, configure the value to go into a latch window style comparison mode. And here we send a high limit as well as the low limit. The low limit is set at 0, so it will never go off. High limit is set at 1,000 lux. So every time you go above 1,000 lux, it will actually trigger that. It will set that pin to low, and which will trigger one of our GPIO interrupt. So this way that we will never have to actually communicate with the sensor until it is actually generating. Until it's actually detect that it has a fire alarm. So this is to generate set the GPIO for the buzzer. We enable the ADC conversion time, start the timer for watchdog clear, and we disable. You can see that we disable the I2C because we're not going to talk to the sensor anymore because now the sensor is on its own. we enable the watchdog timer. So like I said from the previous video, my code concept is completely event driven, which means that there is nothing in the while loop other than going to low power mode. Low power 0 will go this mode is where any interrupt happens will wake it up from that mode. So you have a physical, let's go through the three main trigger interrupt, which is the switch, the ADC, and the light sensor interrupt. The light sensor interrupt is actually a GPIO interrupt. So let's go into GPIO. This is for light sensor. So every time this interrupt triggers, that means that you have a light intensity that's above the threshold, and it's setting the pin low. So we check for the pin interrupt flag, and we clear the flag. We actually reinitialize the I2C, and we read the configuration register within the sensor. By reading the configuration register, we clear that pin, so that pin goes high again. And after that, we actually set the flag for fire alarm active. This means that all other interrupt will see this flag and won't set up their alarm, because this alarm takes priority. And then we go off and start the fire alarm. Okay. And then the other interrupt is right here, the switch, doorbell switch. So this is similar to the light sensor interrupt because it's a GPIO interrupt. Port 5 pin 1, the switch, which is a switch 2 for on the booster pack. So within the interrupt, we check for fire alarm active. If it's active, then we don't ring the doorbell. If the burglar alarm is active, then we don't ring the doorbell either. But even if either of those are active, we actuate the doorbell. So the other third major interrupt is the ECE461 ISR handler. So when the ADC triggers this interrupt, that means that the threshold for the burglar alarm has been reached. So within the interrupt, you check, see if the burglar alarm is armed or not. If it's not armed, you don't trigger the burglar alarm. Now, if the burglar alarm is active, it's already active, so you also don't trigger the burglar alarm. And if the fire alarm is active, you don't trigger the burglar alarm. But if all these are not active and the burglar alarm is armed, you trigger the burglar alarm, you set the burglar alarm to active. Okay. So now we can look at these alarm function that I called in every one of the interrupt. So it is pretty much just a function that sets up a recurrence of timer. So you set up 2 timers, and then you set up the doorbell frequency, and then it goes off according to the frequency, and it will repeat itself. This is the doorbell. This is the fire alarm. Pretty much setting up a timer again, setting up 2 timers, actually 3 timers, because one of the timers is to change the tones. The other timer is to change the actual period of the sound, because I try to model the actual fire alarm, so it's a little more complicated than just a single tone sound. Same with the burglar alarm. So everything is interrupt based. There's and timer and interrupt. That's the biggest thing in this entire program. So my program is fairly simple, but I think it's very efficient as well. But that's all I have to say about my program. Thank you very much. Sorry, one last thing about the program is that try to optimize memory space. I use all flags. All these flags that I have, all these flags are masked for one register. So every time you enable it, you end these value with the register to mask it, just like a real register flag, just like a real register. So this will optimize the space. Thank you very much.